Absolutely.
Now we're
Over here, we have our foundation wall. I won't push too hard on it. Yeah. But you have your concrete reinforced foundation, typically at about 8 inches. And in here you have rebar with the cement, reinforcing it. And in this case, we're showing you part of the main beam. On new construction or newer construction, your beam is usually going to run front to back. And your joist will run across. So they'll take the shorter path, and the beam will be the longer path. So in this section, they're showing you an overlap on the main beam. We're typically looking for at least a 3-inch overlap on that main beam, joist to joist. In some of the older construction, when we go in, we'll actually see a wood 6x6 beam and wood 6x6 posts, and you'll see full span joists. So we don't have, I mean, you can find that lumber. You have to pay a pretty high premium to get that kind of lumber. You can find that in engineered lumber now, I-joists or trusses, and those typically are rated for the full spanning. A lot of times you won't see this beam or this post in the basement. That allows them to actually do any layout that they want. They can change now. A lot of your new construction is I-joist or trusses, full span, and so you have an open floor plan. And but with the beam, say we're coming in and we're doing an inspection, we have a beam, it's an older house, we have an overlap. This is your center point. So usually your first floor wall is right off of this beam. That's a support wall. Your other walls that are running across are just dividing walls. One thing that happens in some of the older houses that you'll see is you'll see settling in between those rooms. Dividing walls, they didn't double up on the joists that were underneath there. Over time, the weighting of that wall is slowly create a little sag in this joist, and that's some of the sag that you see in the flooring. So, or some of that sag is maybe in a bathroom or kitchen. Your Uncle Joe came in and he ran some new plumbing for your bathroom, and he, oh wow, I got to cut this bottom part out of the joist. I'm going to run the pipe through it. So he's notched the bottom part. The only problem is that's a strong part for this joist. So when you undercut it, you weaken that joist dramatically. The best thing that we look for is, in the standard joist, is actually to leave the the top parts of the joist intact. If you're going to run piping through it, through the middle third.
So bore a hole and
Yeah.
get one of those.
On this joist, the standard joist, your strength is in the middle. So if you're going to cut through the pipe, it's better to actually cut through it off of the ends where the actual bearing is. This is actually where you actually need most of your strength. On an engineered joist, I think we have one, for example, their strength, or their part that they actually need the most strength is the actual end bearing. So you don't want to touch that. So it's a lot of those engineered trusses are open web. You can run through them. You don't have to cut. You don't want to see any cutting in a truss. Any cutting in that truss would then require an engineer to actually, you're changing the whole structure of it. And trusses are run across basically where you see one right up there. There we go. So you're spreading the load at various points. If you take out one piece or one bracket in there, you weaken the whole structure. So you never want to see those cut in the field, as they say. These, like I said, if you leave the top third and the bottom third intact, you're typically fine. In this case, we have a 2x8 in here, so you could probably go maybe with a 2-inch line run through here. I don't think you want to take too much more out of this joist. But if you had a I-joist, I'll have to get him to put one in. Basically, you have a web on the top and the bottom, and you have a board that looks like a oriented strand board. You see some of that like right over in here. This is a press board. And what that does is basically lay it on the side with that webbing. You can actually cut through any point in that OSB and that full I-joist that runs across. As long as you don't touch the top and the bottom cords on that joist is intact structurally. It's actually designed. So One thing that we do see, electrician comes in and he'll notch the bottom part and run his electrical so you can fit in drywall without having to put a footing strip. If he does that with an I-joist, then you need an engineer to come in and repair the I-joist, because that bottom part is integral to the structure of that I-joist. And the I-joist actually can, depending on the sizing, can span 25 feet, 20 feet. It just depends on the size. But in here, posts, beam, we have a plate. This is an adjustable column. We're typically looking for solid columns in the basement area. Some of these are rated for permanent use. Some of these are considered temporary. So that's, when we come in and we see that, we'll typically recommend an engineer or foundation contractor come in whenever we see an adjustable column. Because that means somebody can come in and adjust it and actually play with the bearing that you have. So when somebody's coming in and I can come in and put a wrench on this, and while my floor is sagging upstairs, I'm just going to take that wrench and I'm going to spin it up a little bit. You're exerting a force on existing sagging framing, and you could crack any one of those joists or framing in that, and then you have possible collapse issue. So whenever we see that, we're typically looking at maybe even having somebody come in and actually welding that section on there if they need to, just to prevent it from being adjusted. Here we have drainage tile for a foundation. This is an example of new construction. The drainage tile is run around the perimeter of the foundation. You can see, I don't know if everybody can see, but basically it runs around the outside of the foundation, comes in at a bottom point through the foundation, and feeds into the sump basin. So basically in a new construction, you're taking all the moisture from the exterior directly as it hits the foundation, and you're putting it into the sump, and the sump's ejecting that away from that foundation. On an older house,